We're going to be doing experiment 3 from elementary chemistry R110. We're going to be learning about density, in which we determine the density of water. You're going to learn how to use a volumetric pipette, determining the density of an unknown liquid, and also determine the density of an unknown solid. And one of the aspects is trying to determine volumes of solids that have unusual shapes by looking at water displacement. Okay, when you're doing your labs, make sure you have your procedure and your data tables with you, because you're going to record all of your values and measurements directly on the data table, not on random slips of paper to be recorded at a later date. So to do part 1, you're going to need a dry 50 milliliter graduated cylinder. You're going to weigh that on your balance, and then you're going to add about 40 to 45 milliliters of deionized water. Does it have to be exactly 40 or 45? No. You're going to add that much, and then you're going to read it so you know exactly what the volume is. Okay, noting with the bottom of your meniscus. You're going to weigh your graduated cylinder with the water now, and you're going to take the temperature of the water in your graduated cylinder. Okay, so here's your dry graduated cylinder, and you can see that what its weight is. Then when you do this, make sure that you went through, turn on your balance, make sure it's 0, and then put it on. So after you add in your DI water, okay, you're going to reweigh it. And from here, remember where the bottom of the meniscus is, you are going to get the volume of your water. And then you put in your thermometer at the very end, and you let it sit there for several minutes. So you could actually start on getting all the equipment for your next lab while you're waiting for this to equilibrate, and then record the value. You're going to need this table from the CRC handbook, and what this table gives you are the densities of water based on your temperature. Okay, so these are all the temperatures. So if you had a temperature of 20.9, you would read this line and you go all the way across to the 9. And what we'll do is we'll talk about how to read the density of water from this table. Okay, so what are the values you need to record? The mass of the graduated cylinder dry, the mass of the graduated cylinder with the water, the volume of water, and the measured temperature of water, and we will go through and show you how to get the value for the density of water from the CRC handbook. Okay, so this is an example. So these are not the values that you're going to see from your slides. Okay, this is just to show you how to do the calculation. So be aware, these values are not any values that you see from the actual data. So, for instance, in here, suppose your dry graduated cylinder is 75.28 grams. And then you record that the graduated cylinder with water is 115.72 grams. So this is line 1, this is line 2. If you subtract it, the difference here goes here. That is the mass of water that you'd put into your graduated cylinder. If you read your 50 milliliter graduated cylinder, we know we can read to the 0.1 milliliter. And suppose the bottom of the meniscus was here, so it's 40.3 milliliters. If you look at your thermometer, suppose it read 21.8. So when you do density, make sure you know this equation. Okay, that's one that you really ought to memorize, is mass divided by volume. So the mass you determine to be 40.44 grams. The volume you determine to be 40.3 milliliters. So we'll talk about the rules for significant figures, but what you end up with is 1.00 grams per milliliter is your density. So why did we get the temperature? If we look at the temperature, what we do is we say it's 21.8 degrees. So we go on degrees and say 21. So you're going to look at this row on your sheet, and you're going to go all the way across to the 8. And it turns out the first 3 digits remain the same. So it's a 0.997. That's why it's underlined in orange right here. That hasn't changed. But as you go across and even down, you see there's nothing here. It's because that part's the same. It's the last 3 digits that change. So if I was 21.0 degrees, the density would be 0.997992. If I'm 21.8 degrees, then you go across, and it'll be 0.997815. So that's how you read your density. Now this equation you need to memorize, okay, as well. And it's percent error. And it's your theoretical value, like or true value, which is what you got from your handbook, minus your experimental value. This is what you obtained when you did your experiment, divided by your theoretical value. So when we do this, from your CRC handbook, this is the density for water that we obtained. From your calculations, this is the density that you determined from your measurements. That's your experimental value. So when you've put everything in, these vertical bars means absolute value. So it doesn't matter if your subtraction is negative, you'll always get a positive number here because it's absolute value. So when you subtract it and then you divide it by the theoretical value times 100%, we get 0.2%. And how we determine the significant figures, we will review in week 2. Okay, what about part 2, determination of the density of an unknown liquid? Again, make sure you write all your information directly on your report sheet. You will get a 10 milliliter volumetric pipette. You have a clean, dry crucible with the lid, okay? And I'll show you the video on how to use your pipette. You're going to transfer exactly, and it's not even 10.0, it's 10.00 milliliters of the unknown liquid to the weighed crucible. All right, and you're going to record your unknown number. And they're going to weigh the crucible, lid, and the contents, calculate the density of the liquid, and then I'll give you your true value, and then you can calculate the percent error. So in this case, here's the mass of my empty crucible, okay, with the lid. All right, and then let's go through on using a pipette. Okay, with a glass pipette, it is calibrated, it goes to 1/100th of a milliliter. So the 10 actually tells you this can measure exactly 10.00 milliliters. There's only one line on here because basically you're going to get the bottom of the meniscus of your solution at this line. You can't get it above or below. It's calibrated exactly 10.00 to this line. How do you get your solution in here? Don't use our mouth and suck on it. You can use a pipette bowl. The way the pipette bowl works is you have 3 ball bearings. Okay? The top one, if you release it, you can squeeze the bowl and all the air in the bowl comes out. Okay? If you want to add air back into it, okay, you can just squeeze this again and the air will come in. How do we do it with our pipette bowl and our pipette? What you do is you put the pipette bowl at the very top, so it's sealed on the top of my glass pipette. You squeeze the ball bearing and remove all the air. Okay. When you do that, then you bring up the volume of water. You're going to squeeze the ball bearing that says S. And when you do that, you just gently squeeze it, and you can see that I'm bringing up the solution. Okay. Now, this part is slow, but as you get to this narrow part,
You want to be very careful because it'll rise quickly and you don't want to contaminate your bowl and your solution. So you go up to the point, and at this point you say, oh, I'm too high above my line. If you want to add airing to get this to expel, that's the E for expel, you just go ahead and you hit the E ball bearing until the bottom of your meniscus is just on that line. Okay? And once it's on the line, you now can transfer it over to your container. You can hit the E, or you can just take off your bowl and let it drain. When you let it drain, make sure the very bottom of the tip touches the glass, because that will help the flow rate, okay, of your pipette. So once it's done, you will have transferred exactly 10.00 milliliters of your solution. And if you notice, there's just a drop of solution at the very tip of the pipette. Do not blow that out. Part of the calibration includes that. So what you delivered, okay, is exactly 10.00 milliliters. Okay, so that's how you use a pipette bowl right here. What happens if you say, well, I don't have a pipette bowl? How does this work? This is what we call a pipette pen. And if I push down on the wheel, then basically it will start sucking up the liquid. Okay, so if you loosen it, this makes it loose enough that you can fit in the tip of your pipette. Once you do that, you can tighten it, but don't over tighten, just finger tighten it so that it's snug. Put it into your solution, and as you push down on the wheel and this starts to come up, you should see, okay, that I'm pulling up my solution. Okay, so and then, once you get it to exactly where you want your meniscus, so let me just go ahead, this is, okay, so I waited for the meniscus to go to this line, and then again, I will, hold on 1 second, there we go, right there, then we transfer it. Okay, now when you transfer it, how do you get it to go? And all you have to do is you can just loosen the pipette pen off the top. And again, you can see just by gravity, the pressure pushes your solution out. So that's how you use a pipette pen. Okay. So either system will work. And again, you'll have 1 drop of solution at the tip, but you've transferred exactly 10 milliliters, 10.00 milliliters of solution, okay, using a glass pipette. When you are done, the way you store it, okay, let me just get you you'll find that we often have an empty beaker, large beaker, with a paper towel at the bottom, okay. When you rinse it out with DI water, okay, deionized water to make sure it's nice and clean, you store it upside down in the large beaker to let it air dry. And this allows all the deionized water to basically rinse out your solution. Air dry, you want to protect your tip because that's really important for the calibration of your glass pipette.
And transfer our solution.
Okay, so for part 2, I'm actually going to be using solution number, unknown number 116. Okay, so what you're going to do is you're going to transfer exactly 10.00 milliliters using your glass pipette. Okay, in this case, I like using pipette bulbs. So I've squeezed out the air, inserted it here. Now you can just put in your container, just carefully get your 10 milliliters. Okay, and as we've talked about and how to use a pipette, just be careful once it enters. Okay, let's go ahead. Looks good. All right, so let's go ahead and transfer it. So I usually take off my bowl, put the tip, just to lightly touch the side when it transfers out. Okay, you can see that it's transferred out. There's that remaining drop. Blow it out. Always reseal your lid so there's no spills. Minimize that as possible. Put the lid on, and now this is ready to weigh on your scale.
So now that we've transferred our unknown liquid, it was in our example for the demonstration number 116, we now know that when we put it back on the scale, it weighs 53.52 grams. So once we record that data, we need to then calculate the density of our unknown liquid. Okay, so in your data table, you have the mass of your crucible and your lid. You have the mass of the crucible, lid, and liquid, and then the volume, and you're going to calculate the mass of the liquid. In this case, we're talking about doing an example, so these numbers are not what you've seen on our demonstration or what you may encounter when you're in lab, but it's just, like I say, so we can go through the calculations so you know exactly what to do. To get the mass of the liquid, you're going to have to subtract line 2 from line 1. So 57.69 minus the 45.28, gives me the mass of liquid at 12.41 grams. When we look at the density, remember density is equal to mass divided by volume. So we have our mass here. We know the volume of liquid because we use a 10.00 milliliter volumetric pipette. So we know that our density is 1.241 grams per milliliter. So what do we do with this data? You'll also be given your known value, your theoretical value. This is a number that you should have gotten. And suppose for our case, our example is 1.135 grams per milliliter. In that case, you take your value that I gave you, which is the theoretical value, minus the value that you determined from your data, divided by the value that I give you. And this, following this formula, gives you percent error. So our percent error for this example is 9.34%. Okay, part 3 of experiment 3 is determining the density of an unknown solid. So you're going to have an unknown solid, you're going to record the unknown number, you're going to have a weigh boat, you record the weight, you're going to put the solid on the weigh boat and you're going to record that. You're going to add 30 to 35 milliliters of DI water to your 50 milliliter graduated cylinder. You're going to record the volume, and then you're going to carefully slide at an angle your sample into the graduated cylinder so we don't splash and you lose water. And then basically, you after the water settled down, you're going to take a look at the level and you're going to determine that volume. So let's go through an example. So here I have an empty weigh boat. So we know what the weight is after we've turned on our scale and zeroed it. Then we have an unknown solid. In this case, for the demonstration purposes, it's unknown number 53. And we put it on the scale on the weigh boat and we record that value. After we have our graduated cylinder, you're going to fill it up between 30 and 35 milliliters of water. So we filled it up. You're going to read that volume based on the bottom of your meniscus. And it's going to be, that volume should be to the 10th of a milliliter. Here, you slide in your solid, and now you can see that the volume has changed. So now we read it again, and again, it's to the 10th of a milliliter. So record that value, and now let's take a look at our calculations. So here's an example of our calculations. This is, of course, not values that we used in your demonstration or what you may obtain when you do the lab yourself. And that is, you're going to be looking at the mass of the container. Okay, that's your weigh boat. You're going to have the mass of the container and sample, and that's going to have your solid sample on it. So you're just going to subtract line 2 from line 1, and that'll give you your mass. Okay, for the volumes, we have the volume of water that you put into your graduated cylinder, and we recommend between 30 and 35 milliliters. What happens if you put in 38? You're fine. Okay, so don't feel like anything happened. What happens if you put in 25? You're still fine. Why do we recommend between 30 and 35? Just because you know you won't go over 50 mils and not be able to read your volume, and you have a really better way to read it. If it's too small, it's hard to read the differences. Okay, you have your sample in your volume of water. You read that, and notice since it's a 50 milliliter graduated cylinder, we are reading to the 0.1 milliliter. You subtract line 1 from line 2, and that gives you the volume of your solid sample. So the density is equal to mass divided by volume. So what we have here is the mass was 85.14 grams, the volume was 9.9 milliliters, so we get a density of 8.6 grams per milliliter. If this volume is larger, and it's 3 significant figures, then that'll be 3. But in most cases, you'll have a 2 significant figure answer. The density, you're going to get it from the instructor and not the CRC. Okay? And the density in this case, for this example, was 8.96 grams per milliliter. So let's go ahead on the next slide and talk about how to calculate percent error. So with the percent error, remember, you have this formula memorized, and we'll be using it again and again. The value from the instructor is your theoretical value. The value that you obtained from all your data in the lab is your experimental value. And in this case, 8.96 minus 8.6, absolute value of that, divided by 8.96 times 100%. Notice your units cancel out, so it's a 4% error. And that's how you calculate your percent error.